Problem 2. Solving an equivalent system. What is the solution of the system? Use elimination. We can see three equations at the right, numbered 1, 2, and 3, and we can consider what you might think on the left-hand side and what you may write in the box on the right. First think, pair the equations to eliminate y. Multiply equation 1 by -1 and add it to equation 2. Then multiply equation 2 by 2 and add it to 3. And so as you do that process here on the right, equation 1 times -1 becomes -x minus y minus 2z equals -3, and equation 2, written below it, 2x plus y plus 3z equals 7. Adding these two equations eliminates y and gives us an equation with just x and z remaining. That is marked here equation 4, x plus z equals 4. Then we multiply equation 2 by 2. That becomes 4x plus 2y plus 6z equals 14. And equation 3, written below it, -x minus 2y plus z equals 10. So we have a pair of equations here with opposite numbers of y's that we can use to eliminate y and form one more equation that only has x and z remaining. Adding these two, we get 3x plus 7z equals 24. And that's marked as equation 5 for our convenience. Next think, multiply equation 4 so you can add it to equation 5 and eliminate x. So currently we have in equation 4, x plus z equals 4, and equation 5, 3x plus 7z equals 24. It says we need to multiply equation 4, but we're not told what to multiply it by. What we're trying to achieve, though, are opposite numbers of x's. Currently there are 3 x's in equation 5, so we need to multiply equation 4 by -3. That leads us to the equation -3x minus 3z equals -12. Equation 5 right below, 3x plus 7z equals 24. Adding those two equations eliminates x's. And now we have an equation with just z, that's 4z equals 12, so z equals 3. Now that we've found a constant value for one of our variables, we work backward, substituting values in. First, z equals 3 into one of our two equations that only has two variables. In this case, x plus z equals 4, but we substitute 3 for z to find that x plus 3 equals 4, and x equals 1. So now we have z for our solution. We just found x for our solution, and we'll use both of these in one of the two original equations in order to find the value of y. Then think, substitute the values for x and z into one of the two original equations, in this case equation 1, to find y, and check the answer in the three original equations. So substituting 1 for x and 3 for z into equation 1, we find 1 plus y plus 2 times 3 equals 3, and solving we find that y equals -4. So now we have a solution. 1, -4, 3, an ordered triple, and we can check it. We check by substituting into all three of the original equations, and it checks out in equation 1, in equation 2, and in equation 3. So we can confidently state the solution is the ordered triple, 1, -4, 3. Your turn, part A. What is the solution of the system? Use elimination. And part B, a reasoning item. Could you have used elimination in another way? Explain.